Hello, everyone, and welcome to this technical walkthrough of Belong's first audit competition hosted on Immunify. I am Shruti, Hacker Programs Manager at Immunify, and I'll be guiding you through today's session. We're excited to have Bodan from the Belong team joining us today. He is one of their core technical experts and will be sharing an in depth look into the protocol and its security model. Here's a quick overview of Belong Network and the audit competition. Belong is building the world's first performance based affiliate network for physical businesses, combining real world experiences with on chain technology to transform how venues, promoters, and customers interact. Through its flagship product, Belong CheckIn, venues pay only for verified customer visits and spending, ensuring marketing efforts directly translate to measurable outcomes. The platform rewards promoters with visit bounties and a share of customer spend, all tracked transparently on chain and paid instantly in long tokens. With a seamless Web 2.5 approach, Belong eliminates the need for crypto wallets, making blockchain participation accessible to everyone. Beyond check-in, the Belong ecosystem enables tokenized venues and events, AI-driven community engagement, location-verified rewards, and on-chain bounty programs that bridge digital and physical interactions. Available on web, iOS, and Android, Belong is redefining how physical spaces connect with digital communities through trust, transparency, and automation. For this audit competition, participants will be competing for a flat reward pool of 30,000 USD, aimed at uncovering vulnerabilities across roughly 4,000 lines of Solidity and Cairo code. Beyond the main pool, this competition also includes an exclusive prize pool for members of the All Star program and a podium pool that recognizes and rewards the top three researchers of the competition. Today, Bodan will walk us through the design and structure of the code base and outline important security considerations and also highlight the areas of particular interest for security researchers. Let's dive right in and over to you, Bodan.
Yeah, hi everyone, and let me show you my screen. I think that my screen is sharing, yeah.
Yes.
So, in terms of smart contract side, we have a complex decision to make it structured and built like very well. So, in terms of smart contracts, so we have two main smart contracts. Is factory. Factory is responsible for deploying all of the required smart contracts, like tokens, like Western wallets, like route to the receiver, and I think that's all. Also, it's responsible in referral system, but I'll go with it a bit later. Yeah, so if you're going to deeply dive into this smart contract, factory is built with Solidity libraries. It is an upgradable smart contract, and this smart contract has been deployed to some of the networks like Ethereum, Polygon. But yeah, we have an upgrade of this smart contract to deploy more tokens, and previously this smart contract was built on on create functionality, but now we're using minimal proxy clones for the deployment of different tokens and yeah. So in terms of functionality, so we have produce function which deploys access token, and access token is used for NFT ticketing. So access token is like some ERC20. Oh, sorry, ERC 2021 token, which can be used as tickets for different events. Yeah, so this function can be called by anyone, but it requires a signature, EAP 712 signature, which will be produced by our backend. Um, yeah, so this function, using this function, we also can deploy royalties receiver if, as you can see, fee numerator is more than 0, greater than 0. Yeah, and royalties receiver is used for payment splitter between different addresses. And as you can see, here we are deploying access token, which is ERC 721 token. Yeah, so also we have produced credit token, and credit token is an ERC 1155 token, which will be used and can be used as venue and promoter tokens. Venue token is used for representation of USDC baked value. Like if venue wants to deploy, let's say 100 USDC, it will be minted 100 with some 100 venue tokens. And in terms of promoter token, it will be when the venue token will be burned, will be minted some promoter token, and promoter will get some reward and can get some reward. Yeah, and also factory deploys Western Wallet, and Western Wallet is used for Western schedules. Western schedules can be very flexible. And let's say a Western schedule can have some TGE, or like it's start timestamp, also cliff, and the duration of this Western. What else? So yeah, it has also ownable functionality. So an owner of this system can configure some parameters of the factory, like some specific addresses, implementations, etc. Yeah, and second, sorry, and we have also extension for factory. Referral system. Referral system is used for referral codes that can be shared between different venues or NFT creators. And referrals will get some fees from the some actions. Let's say if I invite someone to our platform, then I became a referral, and I can get some fees from this person that I invite. Yeah, so anyone can create a referral code, and this referral code will be used for this referral representation. Yeah, we can also set referral users to count how what's the amount of users used this referral code for specific referral creator. And the second main smart contract is Belong CheckIn. And this one is used for when you Like for venues, it's promoters and customers that can pay to this venue. So we have promoter staking and venue staking. And let's say in terms of promoter staking, we have some tiers. And these tiers are relies on the amount of tokens that promoter staked. So let's say, let me check the, yeah, so let's say if 0 long has been staked, then we have 5% fees and 10% fees. If 50,000 longs has been staked, then long fees will be 4%, and so on till the one. As well for venue staking, so if venue has no stakes, then it will be some 10% of deposit fees. And like moving next, if some venues want to stake and staked some amount of longs, it will be reduced to 9, 8, and even till 5%. Also, we have some fees configuration for different cases, or what I can explain a bit later. And it also has some ownable and initializable features. So in terms of what can I? Yeah, let me firstly explain all of the functionalities of smart contracts that Belong CheckIn relies on. So Belong CheckIn connected to V3 factory of Uniswap or PancakeSwap. It depends on blockchain. And like it has some dependencies on factory, router, and quarter of these dexes. Also, we have escrow, staking, and credit token. So, and as well as some libraries like signature verifier and help. So in terms of escrow, escrow is a smart contract where you, where is all of the funds stored on. So when someone deposits some amount of tokens, it will be stored here, like as in regular escrow. Yes. For the deposit, we have like firstly, it will be sent from some smart contract, and then it will be stored in venue deposit. We are sending this amount here. So we are sending to escrow using safe transfer from, and then we are storing the deposit in escrow. The same as, yeah, USDC and long deposits. Then we can distribute long discount. It will be used for some specific cases. And when you deposit, also it will be used for some specific cases from Belong CheckIn. Staking, as I mentioned, is built on ERC 4626 or tokenized vault, and it will be responsible for this staking and tier granting system. So it's connected to long token. And this is not like very usual staking platform. It has some penalties. So let's say one user wants to stake some amount of loans. He deposited it, but he changed his mind and he wants to withdraw it. And to withdraw this amount of that he staked, he can only do this like after spending some time, because if it's not, then he'll be penalized, and this penalty will be calculated using this calculation. In other and I think that this is the only one functionality that implemented as additional implementation. Yeah. So yeah, we are also storing some information about stakes to calculate this penalty amount. And these calculations will be in function consume unlocked or remove any shares for. Yeah. In terms of tokens, so we have credit token, and this is regular ERC 1155, which is built on ERC 1155 base. And 1155 base is built on Solid's ERC 1155 library. It is also initializable. That means that it can be used as proxy. And it has some roles for managing this token, like default admin, manager, minter, and burner roles. And it's quite simple. So manager can call some managing function, like you said, URI or transferable or not. Minter can mint, burner can burn, and default admin can grant all of these roles. What else? Yeah, so it is also checking if this token can be transferable or not. If it's not, it that means that users cannot transfer their tokens to anyone. Yeah, in terms of credit token, I think that's all. In terms of long, so this token contract has been built using OpenZeppelin Wizard, like fully built, so no changes has been added. So I don't think that, and I think that OpenZeppelin Wizard contracts are heavily secured, so I don't think that it should be some issues here. And the last one, access token, which is used for in factory, but I think that we can come to this later. Yeah. And so, yeah, in terms of Belong CheckIn, Belong CheckIn, so the flow is some user who became a referral using create referral code can share to venue this referral code. And venue can go to our platform and call venue deposit function. It is possible also if venue has no referrals, but then like this referral called an affiliate will not get any fees. In terms of venue deposits, so we are given some free deposits to venue, which is calculated using these checks. So let's say initially it will be some only two deposits without any fees. And after these two deposits, venues will be it will be some fees to these deposits in this case. Yes, so venues can set their rules. Rules rules can be found here in structures.so. So rules, venue rules consists of payment types. So where it is? Yeah, or using so customers can deposit to venue using only USDC long token or using both tokens as well as USDC and long. Bounty types. So bounties will be given to promoter who invited the customer. So let's say promoter has his code which generated in referral system. This code can be shown as QR code or something like that, and this QR code will be shown to the customer. And if the customer has some promoters can get some visit bounties and spend bounties. Visit bounty is when the promoter invited the new customer, like fully new. And spend bounty this is when customers spending some funds on our platform. So yeah, this bounty types responsible for these rules. So if venue wants to reward promoter with visit bounties, with spend bounties, or with both bounties, like visit or spend and spend. And in terms of long payment types, so after payment from the customer side, yeah, so we can after stake to the staking platform the funds that venue receives, or after converted to from long to USDC. Yeah, so this is in terms of venue rules. What else? Yeah, as I said, these funds from venue will be stored in escrow, and venue will receive venue token. It's the same amount as deposited in USDC. So pay to venue is a function which will be called from the customer side. Oh, and forgot to mention that all of these functions will be checked with AP 721, like signature verification. As well as here. Yeah, so venue will have his own ID, and this ID generated from yes, just from his address. And using this venue ID, customer can pay to venue. So as I said, if the venue has some promoters and this promoter has been specified, then we have promoter will have some rewards depending on the spend bounty and visit bounties. If will be like when you have some promoters, then venue tokens will be burned and promoter tokens will be minted in the same amount of burned venue tokens. So actually, venue tokens is used for promoting. So venues are depositing their funds laterally to reward their promoters, I guess. Yes. So in terms of payments could be done in two tokens, in long and in USDC, as we saw in rules. If everything is okay and payment in USDC, then it will be some USDC's payment to from customer to venue. If the payment will be in long, then we will have some subsidy and all of this mess will be calculated to get a long amount that will be sent to venue. And the last main function from this smart contract is distribute promoter payments. So when the promoter received some promoter tokens, he can try to withdraw this amount. It will be also checked using signatures that will be signed from our backend. And we have also staking information that I shared with you when the promoter withdrawing his rewards, then it will be taking some fees. But with this staking, we can reduce this fees amount that will be taken from the promoter side. Yeah, and also promoter can choose in which token he can receive these rewards. So if it will be in USDC, then it will be just a regular transfer from escrow with fees to platform. And if promoter choose some payments in long, then he'll get some bonuses with lower fees, and he'll receive his rewards in long. At the end, all the promoter tokens that sent in long or USDCs will be burned. It has also some emergency kill function. If some of the deposits seems some suspicious for us, we can cancel it because we can cancel it, and everything will be reverted, I can say. Yeah, also we have some setters which will be protected by only owner function, as well as set rules, set contracts and rules. In terms of swaps, it will be used some DEXs like Uniswap or PancakeSwap third version. And you can find it here in the swap flow. And handle revenue. This is for swapping some long and burning them. So you can find it here. And build path is for getting the correct path of liquidity pools and swaps. So it will be used some multi-hop swap. So or three, yeah. So it will be used in exact input. Okay. So in terms of the main functionality, it's done, but also we have some libraries. And the first library is helper, and this library is for checking some tiers that I explained to you, like no stake, bronze tier, silver, and till platinum. Gateway new ID, and for standardization, because ESDC has 6 decimals, and our long token will be with 18. So we need to standardize it, and these functions will this function, and this function will be used for standardization and unstandardization. Also, we have some helpers for math and for get price. So we have probably will have some price feeds from Chainlink, and from Chainlink price feed, or like Chainlink compatible price feed, we can get correct price of long USD. And with this price, we will calculate some information in Belong CheckIn in swaps, as I remember. And the last library is signature verifier. And here we are checking all of the signatures. So we have signer. Signer is our backend. And before each instruction, backend will sign the message using some data, as you can see here, here, and in all of the functions. But here we also implemented some additional checks like name length and symbol. Also we implemented some checks for payment types. So if customer provided information about payment in USDC and it's true, then we should check if it's really true in terms of any rules that was set by Vine, as well as for bounty types. So we can check it here. What's left for us? So yeah, access token. Access token can be deployed by the factory using the produce function. And these tokens, as I said, will be used for different events, ticketing. So yeah, it is also initializable, and it's UEPS proxy, because we may have like a lot of smart contracts of access tokens, and we may have like maybe in the future we'll upgrade them. So yeah, it's easily to have them in UPS instead of transparent upgradable. Yeah, so these tokens has also some royalties implementation. And yeah, so some ownable setters. And in terms of mint functions, so we have two different cases. So we may have static price and dynamic prices. So in terms of static price, so we are specifying the whitelisted and not whitelisted prices, and depending on these prices, we will take some specific amount of native currency to mint the token. But in terms of dynamic price, we should specify it from the backend side, and it will be also checked in a signature verifier. In terms of the payment, so we also have some referrals, and these referrals, which also can be created using the referral code creator. So yeah, this referral code can be used in all of the cases, like affiliate, like referral, and promoter. And one user can be all of these persons. And in terms of referrals, so we are specifying the referral code. And this referral code will be stored in access token also. And later, we will check some referral fees which will be taken from the payment and distributed to referral creator. We also have some fees, and these fees will be going to platform. And in terms of currencies, so we have native currency or some custom token. It can be different tokens like USDC or our long token. And it will be also taking some fees as well as to our platform or referral. But the main amount will be sent to creator of this event, actually. And we are also checking if this token is transferable, and if it's not, then users will not be able to transfer it. But it's also has some connections with OpenSea. So for OpenSea, we implemented this creator token checks. And what else? Oh, and the last one, Westin wallet. This smart contract is built on top of Open Zeppelin, but it has some upgrades, as you can see with some dependencies. And it's also EPS upgradable instead of transparent upgradable, because we have we may have many of these smart contracts, so we may have to upgrade them all. Yes, so as I said, so we have trenches, some start timestamp or TG, and cliff. So let's say if duration is 0, then the linear vesting will be disabled. If the duration is enabled, then we will have some length of linear vesting. And let's say if we are deploying this vesting wallet from factory, and in factory we're also sending some amount of tokens, actually longs, that will be transferred to the wallet, and then can be distributed to affiliate. Trenches is used for configuration is also, and we have add range function, which is only owner, and it can be set only before finalization. And when the trenches are added, and we can finalize it, and after that we cannot configure this trenches adding. And also, like trenches should be in the correct order, because like from start till the end, and cannot be in different orders, because it will be like some reward, and it will be rewarded if it's not in the correct order. To release the loan payments, it will be checked uh, using vested amounts. And vested amounts is like to check the TG, step-based using trenches, and linear using duration and cliff. The rest of the functions copied from OpenZeppelin, and this is also for UPS. So I think from my side, that's all that I can share with you. Thank you.
Thank you for the detailed walkthrough of the code base board. And I just wanted to ask you a few questions. Are there any different access control roles within the project or any external dependencies that white hats have to be, you know, mindful of?
Yes, so as I said, our project relies on Uniswap or PancakeSwap. This is like one of the main dependencies. And actually a third version of both of them. And in terms of additional external dependencies, I think that we'll have some price feeds for long built on by Chainlink or on top of Chainlink or compatible. So these price feeds will be also some decentralized or something like that.
Got it. And what are some of the important bugs that you've probably received in the previous audits that you didn't expect to see? And those are areas you would want security researchers to focus on.
Uh, as far as I remember, the last audits found some. Let me check. Yeah, so it had some highly permissive, as I remember, that we removed from the current version. Also, it also relies on royalties receiver that we also fixed, and it was because of some incorrect payments in royalty receiver.
Got it. And any tips or suggestions that you want to give the security researchers before they get started looking into the code base, or any good resources that you recommend?
Yes, so what we want to get is like that our smart contracts are secured and like it will have no vulnerabilities like reentrancy attacks, maybe some sandwich because or front run attacks because we have some dependencies on Uniswap or PancakeSwap pools. Also, we need to check that the math is correct in terms of these fees, in terms of these calculations, and so something like that. And I think that's all. Like in terms of topics that I can recommend is to read Uniswap documentation and maybe Uniswap documentation, I think.
Sounds good, Vaden. I think we're good to go. We hope this walkthrough has provided a helpful overview of the code base and what to focus on during the audit competition. And if you have any follow-up questions, you can reach out to the Belong or the Immunify team directly in the audit competition channel on Discord. You can also find full competition details at immunify.com under the Explore Audit Competitions tab. For a recap, the competition is live now and will run until the 29th of October. There is a $30,000 flat reward pool, including a native token airdrop for bug submissions, which will also include the All-Star and Podium pool. No KYC is required for this competition, and duplicate and insight reports are eligible for rewards. A big thank you to Bodan for joining us and sharing his insights, and to all of you for watching and participating. We look forward to seeing your findings, and as always, happy hunting. Thank you, everyone.
Yeah, happy hunting.